Okay, question 1. Nice sort of introduction to the paper, this question. Given that theta is small, a clue there in radians, show that the equation cos theta minus sine a half theta plus 2 tan theta equals 11 over 10. Actually, no, don't show that. That's the equation that we've been given. Show that that can be written as 5 theta squared minus 15 theta plus 1 is approximately 0. So we're talking about theta being very small and approximations. So this topic has some information that you should know for this question, and it might take some revision if you do not know these relationships. So cos theta, when theta is small, can be approximately or approximated to 1 minus theta squared over 2. For the sine a half theta, that is going to be approximately just a half theta. And for tan theta, that is just going to be approximately 1 theta. So these will be in your textbook somewhere. Alright, so this is what I'm going to be substituting in for the cos theta, sine a half theta and 2 tan theta. We'll substitute them in down here. So cos theta, 1 minus theta squared over 2 minus a half theta for the sine half theta plus 2 tan theta, which is, well, tan theta is theta, so 2 theta is equal to 11 over 10. Multiply everything by 10, get rid of that denominator, because we don't have one in our final answer here, so let's get rid of our fractions. What is 10 divided by 2? It's going to be 5 theta squared minus 5 theta squared minus a half times 10 is 5, so 5 theta plus 2 lots of 10 is 20 theta equals 11. Simplify, minus 5 theta squared. Now we've got some thetas here. Minus 5 plus 20 will be plus 15 theta equals 11. This has been set equal to 0. So if I push everything over to the right hand side, I'll get a positive 5 theta squared, which is what I've got here. Everything's moving to this side, so I'm going to have 0 equals, I'll write it in order, 5 theta squared, positive now, minus 15 theta, because I've moved it over, and then we're going to get 11, take away the 10 that's moving over, it's going to give me a plus 1. Alright, so that's what we have to show, and because theta is small, then, and we're approximating, you can put that approximation sign in just to give you the final answer. Just check everything is in place, and that is what we had to show. The solutions to the equation, this is a 1 mark question afterwards, sort of a reasoning question. The solutions to this problem end up being 0.068 and 2.963, correct to 3 decimal places. Comment on the validity of each solution. Alright, so we know that these solutions are only, the approximations that we've used, sorry, are only valid when theta is small. And if these are the values of, if theta equals these two values, then this one is small, so this will be valid. I'm shorthanding this, by the way. Try and put this in some nice English for the examiner, please. This one is not small. Alright, so it's not going to be, it'll be treated with caution. Not small, so not valid really. Okay, something like that, just to show the examiner that only small values work with these approximations. If you're not sure, look at the graphs. If you graph cos theta against, graph cos y equals cos x, go to Desmos if you want to see this in action. Go onto a site called Desmos and type in y equals cos x and then y equals 1 minus x squared over 2 and zoom in to the origin, and these two graphs will be pretty much on top of each other. Okay, the more you zoom in, the closer they get when they are around 0. All right, so when they're around x equals 0, they're very, very, very close. That's why you can use them. But if you start to move away or zoom out, then they sort of separate, and they're not as close the bigger the x value that you use. That's the idea anyway. All right, hopefully it's helpful. Bit of extra work for you there to sort of get your understanding in the right place if you're not sure what this is all about.